Welcome. This is the triangle paradox. This is a really fun one. So, look on the left. There's a triangle, and it's made of 5 different shapes: 2 triangles, 3 rectangles. And then on the right, you have a triangle made of the same 5 shapes. Yet, you have something missing. This one here has one extra little square there. So let's take a closer look at this. The first triangle, if you count the base, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 long, and the height 1, 2, 3, 4, 5, 6, 7, 8. So it's a 13 by 8, and it's a right triangle. And to find the area of any triangle, it's just, if you recall, it's 1/2 times base times height. And so the triangle on the left here, you have it's 1/2 times 13 times 8, which would be 52. So you'd say the area of this large triangle is 52. Now let's take a look at the other triangle. So let's count the base of this triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the height, 1, 2, 3, 4, 5, 6, 7, 8. So they both are 13 by 8 triangles. They should have the same area. It'd just be like if they were both rectangles that had 13 length and 8 width. They should have the same area. They're both right triangles. There is no reason why one should have this missing spot here, this one square extra. Now, if you take a closer look, all the shapes that they're composed of have the same area. This pink shape right here, it is a 2 by 8 rectangle, and here it is also a 2 by 8 rectangle. The aquamarine shape here, it's a 3 by 4, and this is a 3 by 4. This large purple triangle here, if you count it, 1, 2, 3, 4, 5, 6, 7, 8, it's an 8 by 1, 2, 3, 4, 5. And this purple triangle here is also a 8 by 5. And then finally, this green triangle here, it's a 1, 2, 3, 4, 5 base and a 3 height. And so is this one. It's 5 base, 3 height. So this first triangle just got rearranged to make the second triangle. You actually could cut this out with paper and actually do this in real life. So you can see I drew arrows to show where the triangles ended up in the other triangle. And somehow when you rearrange them, the area changes. That makes no sense. This is the paradox. How does this work? Now, it is true that two 90-degree right triangles, right, should have the same area if they're both a 13 base and an 8 height. There's no reason that this one on the right here should have one extra area. It is a straight up paradox. What's going on here? What's going on? Well, I'll tell you the answer in 2 seconds here. Just think about it for a second. Okay, so the truth is, yeah, if these were both triangles, it would be impossible. This would defy like basic geometry here, that these two 13 by 8 triangles would have different amounts of area. So the only explanation is that they're not actually triangles, and that is the truth. Now, if you take a look at it, this side here is a straight line, and that is the same with this side, and this here is also a straight line. Could easily verify it's on the grid. You have to look at this slant there. Now, why it looks like the whole thing is a straight slant of the same like degree slope, that is not the case. If you look at the slant of the green triangle, it goes up. Let me do it in yellow here. 1, 2, 3, and it goes over 1, 2, 3, 4, 5. So it is a slope of up 3 over 5. And the purple triangle here, the one here, this slope, it goes over 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5. So it goes up 5 and over 8. Now 3/5 and 5/8 are extremely similar numbers. They're really close. 3/5 of the decimal is 0.6, and 5/8 of the decimal is 0.625. They're so close that you can't tell that the angle of the slope is actually changing. It is not the same. So this is not a triangle. This is a quadrilateral. This side here, and then it changes the slope to have a side here. So it has 4 sides. 1, 2, 3, 4. And then over here, it is rearranged, right? This is also a quadrilateral. It goes at this slope, and then it gets a little bit less steep to do the rest of the green triangle. So it does have 2 different sides here. Again, this side and this side are 2 different sides of this 4-sided figure that appears to be a triangle, but in fact, it's not a triangle. You can do this trick to anybody. If you get a piece of grid paper and you draw this out, they'll stare at it for hours, and most people will not be able to tell you what is going on here. Okay, that's it.